Dear students, I would like to present to you the concept of the normal approximation to the Poisson distribution. जैसा कि आप जानते हैं, अगर बाइनोमियल डिस्ट्रीब्यूशन के अंदर p की वैल्यू 0 या 1 के बहुत करीब ना हो और n जो है वो इन्फिनिटी को टेंड कर जाए, then we can use the normal distribution to approximate that particular binomial distribution. इसी तरह it has been mathematically derived and shown that in the case of a Poisson process, which leads to the utilization of the Poisson distribution, if the parameter is lambda, yani that particular Poisson distribution, whose mean and variance are both equal to lambda, if lambda tends to infinity, then the Poisson distribution tends to the normal distribution. And you can see this on the graph that you now have in front of you on the screen. My dear students, this is not the normal distribution. It is the graph of the Poisson distribution having lambda equal to 30. अभी तो मैंने आपसे कहा था कि लैम्डा इन्फिनिटी को टेंड कर जाए, और देखिए कि in fact even when lambda is just 30, the shape of the Poisson distribution is very, very close to the shape of the normal distribution. Do you not agree? पहली नज़र में अगर यहाँ ना लिखा होता Poisson distribution, तो पहली नज़र में हमें बिल्कुल ये लगता कि we are looking at the normal distribution. All right, this is the first point, that a Poisson distribution tends to the normal distribution as lambda tends to infinity. अब practically अभी देखा 30 पे आपने, लेकिन actually अगर lambda ज़्यादा large हो, for example, if lambda is greater than 1000, then the normal distribution is an excellent approximation to the Poisson distribution. Generally, we will not have lambdas so big. So if, for example, in general problems that we encounter daily, if lambda is greater than about 10, even then, even agar 10 bhi hai to, the normal distribution will be a good approximation if an appropriate continuity correction is applied. आप जानते हैं कि जब हम normal approximation to the binomial करते हैं, तो वहाँ पे हम continuity correction apply करते हैं. तो वो तो exactly वही काम हमें यहाँ भी तो करना चाहिए ना, क्योंकि वो तो इस बात से ताल्लुक रखता है, ये वाला कॉन्सेप्ट, कि एक discrete distribution को आप एक continuous distribution से approximate कर रहे हैं. तो इसलिए वो जो discrete integer values हैं, वो जो points हैं अलग अलग x axis के ऊपर, each one of them should be replaced by an interval, a horizontal interval, जिसका midpoint हो वो particular point. तो अगर वो यहाँ पे भी हम अगर अप्लाई करें, तो 10, 12 इतने पे भी lambda इतना भी हो, even then normal approximation will be quite good. So let me explain all this with the help of an example. Suppose that the number of calls received by an office switchboard per hour follow a Poisson distribution with parameter lambda equal to 25. We would like to find the probability that in 1 hour there are between 23 and 26 calls, including the numbers 23 and 26. Also, we would like to find the probability that in 1 hour there are more than 30 calls. Students, let us try to find these probabilities by applying the normal approximation to the Poisson distribution. अभी थोड़ी देर पहले मैंने आपसे कहा कि अगर लैम्डा 10 या 12 भी हो तो काफ़ी अच्छी अप्रॉक्सीमेशन मिलती है. तो यहाँ पे तो लैम्डा इज इक्वल टू 25, So let us try it. So now, if our random variable is being denoted by capital X, then we would like to find the probability of X lying between 23 and 26. But if we want to use the normal approximation, students, then by applying the continuity correction, 23 expand जो होगा, तो left side पे it will come up to 22.5 और 26 जब expand होगा horizontally, तो right side पे it will come up to the point 26.5. So therefore, the probability that we are going to now try to compute using the normal distribution is the probability of X lying between 22.5 and 26.5. अगली बात कि अब हमें जाहिर है कि स्टैंडर्डाइजेशन का प्रोसीजर अप्लाई करना पड़ेगा क्योंकि हमें जो एरिया टेबल देखनी होती है दैट इज़ फॉर द स्टैंडर्ड नॉर्मल डिस्ट्रीब्यूशन. तो फिर सवाल ये पैदा हो रहा है यहाँ पे कि व्हाट इज़ द मीन and what is the standard deviation of the normal distribution that we are going to use? Well, we are going to use the same mean that is for the Poisson and the same variance too. And we know that our Poisson distribution for this example is the Poisson distribution with lambda equal to 25. लेकिन हम ये भी तो जानते हैं ना कि lambda जो है that represents the mean as well as the variance of the Poisson distribution. So therefore, हम अब normal के लिए भी यही इस्तेमाल करेंगे and we can say that for our normal distribution, mu is equal to 25 and sigma square is also 25, implying that sigma is equal to 5. इसलिए जो standardization का formula अब हमने apply करना है, z is equal to x minus mu over sigma, that can be written as z is equal to x minus 25 over 5. Now, the two limits, वो जो हमें area निकालना है, वो बारी बारी put कर देते हैं. When x is equal to 22.5, z is equal to, as you can see on the screen, it comes out to be minus 0.5. And when x is equal to 26.5, z comes out to be 0.3. Therefore, the probability that we want to find is given by the probability of z lying between minus 0.5 and 0.3. तो पहले तो वो एरिया देख लीजिए जो minus 0.5 से लेके 0 तक है using the area table, that is 0.1915. और उसके बाद वो देख लीजिए जो 0 से लेके 0.3 तक का है, again using the area table, that is 0.1179. Adding the two, my dear students, the total area under the curve between these 2 points comes out to be 0.3094. In other words, we can say that the probability that we wanted to compute using the normal approximation to the Poisson, it is equal to 30.94%, यानी तकरीबन 31%. अब वो जो दूसरा क्वेश्चन है कि we also now want to find the probability of having more than 30 calls in 1 hour. अब हम अभी भी हमें continuity correction लगानी है. हम अगर Poisson के हिसाब से बात करें तो हम ये कह रहे हैं कि we want to find the probability that the random variable capital X is greater than 30. अब इसी को हम इस तरह भी लिख सकते हैं कि the random variable capital X lies between 30 and infinity. अब इसको जब हम नॉर्मल में कन्वर्ट करेंगे तो हमें वो कंटिन्यूटी करेक्शन लगानी होगी. तो ये जो पहला नंबर है 30, जब ये एक्सपैंड होगा तो इट विल बी एन इंटरवल फ्रॉम 29.5 टू 30.5. और दूसरी तरफ जो है दैट इज इन्फिनिटी. इन्फिनिटी में तो माइनस प्लस कुछ भी करेंगे फाइनाइट क्वांटिटी, दैट विल स्टिल बी इन्फिनिटी. So therefore, अगर हम normal के हिसाब से बात करें, तो हमें पता लगा कि we are going to try to find the area under our normal curve from 29.5 to plus infinity. इसको हम यूं भी कह सकते हैं कि the probability that our area is to the right of the point 29.5. यानी जो एरिया हमने निकालना है, that is to the right under the normal curve, it is to the right of 29.5. Again, हमें जाहिर है कि स्टैंडर्डाइजेशन तो करनी ही पड़ेगी. So when x is equal to 29.5, z is equal to 29.5 minus 25 over 5, and that is 4.5 over 5, and that is 0.9. So standardized version जो है उस हिसाब से we are wanting to find the probability of z being greater than 0.9, which is the same as 1 minus the probability of z being less than 0.9. And using the area table, you can say that this is equal to 1 minus 0.8159. वो माइनस कर दीजिए, the answer is 0.1841, which is the same as 18.41%. तकरीबन 18.5%. तकरीबन 18.5% चांस है कि एक आवर में they will get more than 30 calls, whereas on the average, they are getting 25 calls per hour. और इसी तरह जो पहले वाली probability हमने निकाली थी, उसको भी आप interpret कर सकते हैं. So I would like you to actually also compute these particular probabilities that we have computed just now, at least the first one, using the Poisson distribution itself, and then compare the exact true probabilities with those that we have just now obtained through the normal approximation to the Poisson. Hopefully, they will come out to be pretty close.